Hi everyone, I am J Vanitha. I am working as an assistant professor in the Department of Chemistry in Siddharth Institute of Science and Technology, Puttur. Today I am explaining about nanomaterials. In this lecture video, I am explaining what is meant by nanomaterial, classification of nanomaterial, properties of nanomaterials, examples of nanomaterials, and applications of nanomaterials. What is meant by nanomaterial? Any material that have an particle size of around 1 to 100 nanometers. That type of nanomaterials is known as nanomaterial. The term nano stands for 1 billionth of a meter in physical scale length. That means the material thickness is around 10 to the power minus 9 meters. That type of materials is known as nanomaterials. Nanochemistry is defined as the study of synthesis and analysis of materials in the nanoscale range, including large organic molecules, inorganic cluster compounds, and metallic or semiconductor particles, etc. Best example for this nanomaterial is carbon nanotube, fullerenes, graphenes, etc. And next one is classification of nanomaterials. The number of atoms can present on the crystal lattice or the molecular array. Nanomaterials are classified into four types: 0 dimension, 1 dimension, 2 dimension, and 3 dimension nanomaterials. 0 dimension nanomaterials means the materials having all the dimensions within the scale. That means all the dimensions means X, Y, and Z axis. The materials within the scale is known as the zero dimension nanomaterials. Best example for this zero dimension nanomaterial is fullerenes, quantum dots, rings, atomic clusters, etc. And next one is one dimensional nanomaterials. One dimensional nanomaterials means the materials having two dimensions within the nanoscale and one dimension outside the nanoscale. That type of materials is known as one dimension nanomaterials. Best example for this one dimensional nanomaterials is nanotubes, fibers and filaments, etc. And next one is two dimensional nanomaterials. Two dimensional nanomaterials means the materials having one dimension within the nanoscale and two dimension outside the nanoscale, and the type of materials is known as two dimension nanomaterials. Best example for this two dimension nanomaterial is nanodisk, nanolayers, etc. And the last one is three dimension nanomaterials. Three dimension nanomaterials means the materials that are not confined at any dimension. That type of materials is known as three-dimension nanomaterials. Best example for this three-dimension nanomaterial is embedded clusters, equiaxate crystallites, etc. And next one is properties of nanomaterials. Depending upon the size, crystal structure, and surface characteristics, the nanomaterials possess the following properties. And the first one is size. Nanomaterial crystals have large surface area. For example, the nanocrystal of size around 10 nanometers, it can approximately consist of 15% of its atoms on the crystal surface. Whereas the nanocrystal have 1 nanometer size, it can approximately consist of 30% of atoms on the crystal surface. So, size can possess the major role on the properties of nanomaterials. And the next property is electrical property. Nanomaterial can exhibit electrical properties vary between semiconducting to metallic property and depending upon the diameter and chirality of a molecule. Best example for this electrical property is carbon nanotube. And next one is mechanical property. The nanomaterial can exhibit better mechanical properties. Best example for these mechanical properties, carbon nanotubes. Its tensile strength is around 604 pascals, because it is greater than steel. It is the strongest and stiffest one. And next one is magnetic properties. Nanomaterials can also exhibit the magnetic properties or magnetic characteristics. When when bulk material, it can possess less magnetic, whereas the nanomaterial can possess the high magnetic nature. For example, in case of sodium and potassium, it can have bulk material. It can possess the paramagnetic nature, where in case of nanomaterial, the sodium and potassium can exhibit the ferromagnetic nature. And the last one is optical properties. Nanomaterials can choose optical nature depending upon the size and size of the particle. For example, silicon nanowire exhibit photoluminescence characteristics, and indium phosphate can exhibit photoluminescence character. Example for this nanomaterial is, best example is fullerene. Fullerene, in 1960s, the scientist Fuller designed the compound fullerene. It is a C60 molecule. That means the fullerene compound can be designed by 16 carbon atoms. It can be a dome-like structure because it is based on or because it can be fused structures like hexagons and pentagons. And next one is properties of fullerenes. Fullerene is a black powder-like material. When it can be dissolved in benzene, it can form a deep magneta solution. It is very tough and thermally stable, and it is a discrete molecule like allotropes of carbon, like diamond and graphite. Applications of fullerenes means it is used as a lubricant due to its spherical structure. And another example is carbon nanotubes. In 1991, carbon nanotubes was first discovered by S. Limija. Carbon nanotube means when graphite sheets are rolled into a cylinder, their edges are joined together to form a carbon nanotube. Depending upon the way the graphite sheets are rolled, the carbon nanotubes are of two types: single wall carbon nanotubes, multi-wall carbon nanotubes. In the above figure, it is a single wall carbon nanotube. In the below figure, it is the multi-wall carbon nanotubes. Properties. Already we can say that it is a good electrical property, good thermal conductivity. It has a high tensile strength also, and elastic module. And the next one is applications of carbon nanotubes. The carbon nanotubes are mainly used in energy storage, electromagnetic shields, pharmacy, etc. Applications of nanomaterials. In our day-to-day life, nanomaterials can play a major role. It can be used in medical science for cancer treatment, drug delivery, etc. In the nanomaterials can also used in textile industry. It is used as a strain resistant, and it can also used in a battery technology also, like devices like lithium ion batteries. It is also used in sports. The lightweight hockey balls can be prepared by using these nanomaterials. It is also used in environment conservation. In nowadays, nanotechnology is an emerging field in which new and innovative tools to tackle issues of water, air, and soil pollution. Many aspects of nanotechnology, including synthesis, functionalization, and types of nanomaterials, including nanotubes, nanomagnetons, quantum dots, and so on. Thank you.